Are you learning Android development or looking to build real-world Kotlin apps? In this step-by-step beginner tutorial, you'll learn how to build Android apps using web APIs with powerful tools like Retrofit and Coil. In this video, we'll learn how Android JSON can access and use data from the internet, making apps more dynamic and responsive. We'll build a working project, HeartCats, which loads cat images using a third-party API. Along the way, you'll gain experience using tools like Retrofit for HTTP networking, Coil for image loading, and Jetpack Compose for UI. Ideal for computer science students, beginner programmers, or anyone wanting to move beyond static apps and start working with real-world data. A lecture on Android development with web APIs by the programming professor. Let's take a look at the outline for this session. Our main theme is building robust mobile apps that leverage web APIs to provide dynamic content. First, we'll introduce web APIs and explain what third-party APIs are. We'll then dive into building the HeartCats app and learn how to send requests and display the results. Finally, we'll look at handling problems like slow responses or API errors to make sure the user experience remains smooth and polished. Web APIs are a foundational part of many modern apps. They allow an Android app to access and retrieve data hosted elsewhere using HTTP. A typical API is hosted on a server and can be accessed by the app through specific endpoints. For example, a social media app may use an API to manage your connections, help you find friends, or post updates. APIs make it possible to deliver live, up-to-date information without bundling it in the app. Third-party web APIs are APIs made publicly available by external providers. These APIs can perform useful services, such as generating images, providing weather forecasts, or delivering large public datasets like NASA images. Some of these are free, while others work on a subscription model. Many require an API key, a unique identifier that helps monitor usage and ensure fair access by rate limiting how often a client can make requests. A large number of APIs are RESTful, meaning they use HTTP methods and URL parameters to communicate. Data is returned in JSON format, which is easy for Android apps to parse. The Zybooks Quote API, for example, uses query parameters like topic and count to return a list of quotes. Topics can be things like love or humor, and the count can be between 1 and 5. This approach makes it easy to interact with APIs using just a browser or simple tools. You can even try out RESTful APIs directly in your browser. Visiting the URL with topic equals love and count equals 3 returns 3 love quotes in JSON format. You can experiment by changing the topic or the count to see different results. If you request a topic that's not supported, like finance, you'll get a structured JSON error message. Even though the formatting might be dense, apps can handle it easily behind the scenes. HTTP supports multiple methods like get, post, put, and delete, but the one we'll focus on is get. A GET request retrieves data from the server and is the method used when a user visits a URL in their browser. Since the HeartCats app is read-only and doesn't send or modify data, we'll use only GET requests throughout the project. Now let's introduce the HeartCats app. This app displays a scrollable grid of cat images by connecting to the cat API. It includes a refresh button in the top app bar so users can load a new set of photos. The dog API works exactly the same way, so dog lovers can adapt the app to show dog images with minimal changes. This project provides a great foundation for any image-based API integration. The cat API is hosted by that API company and has public documentation and optional API keys. You can get a free key for more advanced access, but the limited version works fine without one. The API's base URL accepts a limit parameter to determine how many images to return. For example, using limit equals 10 fetches 10 cat images, each with its ID, URL, width, and height. That's all we need for heart cats. When the API responds, it sends back a JSON array of image objects. Each object includes an ID, a URL pointing to the image, and metadata like width and height. This structured format is perfect for mapping to Kotlin data classes, which allows us to easily extract and use this data in our app. To begin development, we use a starter project from the book's GitHub repo. It's organized into 3 main packages. HeartCats contains the main activity and application class, Data has the cat image model and repository logic, and UI includes the Jetpack Compose UI and view model. When you run the project initially, it shows a string representation of 5 sample images, but will soon replace that with live image data. To communicate with the cat API, we use Retrofit, a powerful HTTP client for Android. With Retrofit, you define a Kotlin function that maps to a specific API request. For example, calling getCatImages can correspond to the endpoint that fetches 10 cat images. Retrofit handles the request, waits for the JSON response, and converts the result into Kotlin objects automatically. To use Retrofit in your project, add the required dependencies to your build.gradle.kts file. These include the Retrofit core library and a JSON converter for JSON parsing. After syncing the project, you'll be ready to define your API interface and begin making network calls. Next, define the cat API service interface. This interface includes a function annotated with @get, which tells Retrofit that this is a GET request. The endpoint specifies how many images to request. Once defined, Retrofit will use this interface to create a functional HTTP client that your app can use to retrieve data. In the code for cat API service.kt, we declare a suspend function getCatImages that returns a list of cat image objects. The @get annotation defines the endpoint, including the limit equals 10 parameter. This function tells Retrofit exactly how to call the API and what data structure to expect in return. Now let's update cat repository. Instead of returning a hard-coded list, the repository should call the actual API. To do this, we inject a cat API service instance through the constructor and make getCatImages a suspend function. When invoked, it uses the Retrofit interface to fetch real images from the cat API. In the cat's application.kt file, we create the Retrofit instance using retrofit.builder. We set the base URL, specify JSON as the converter, and use the create method to generate the API service. This Retrofit instance is then passed into the repository, so the rest of the app can use it to make network calls. Now that the service is wired up, we modify cat's view model to use it. The getCatImages function launches a coroutine and calls the repository. However, running the app at this point will cause a crash, because the app doesn't yet have permission to access the internet. This needs to be resolved in the manifest. To fix the crash, open Android manifest.xml and add the internet permission before the application tag. This line allows the app to communicate with online services, which is essential for any app that accesses external APIs or resources. When mapping JSON to Kotlin objects, field names must match exactly. But sometimes, APIs use non-standard names like pubyear. To handle this, you can use the @serialized name annotation to map a JSON field to a more Kotlin-friendly property name, like publication year. This makes your code cleaner, while still maintaining compatibility with the API. Now it's time to display actual images instead of just text. To do this, we use Coil, a modern image loading library for Android. First, add the Coil Compose dependency to your Gradle file and sync the project. Then, create a composable that uses Coil's AsyncImage to download and display a cat image from a URL. In the updated CatSap composable, we switch the UI based on the current state. If the state is loading, we display a message. If it's success, we show a single image using the new cat screen composable. If it's error, we display an error message. This approach makes the UI reactive and state-driven. So far, we're displaying just one image. But cat images come in different sizes, and displaying them in a flexible layout looks better. For this, we use lazy vertical staggered grid, which can handle variable-sized content more naturally. This lets us create a Pinterest-style grid that scrolls vertically. In this code, we define a cat screen composable using lazy vertical staggered grid. It specifies 2 fixed columns and includes spacing between items. Each item uses a sync image to load the image, with error handling built in using a fallback icon. This structure displays a responsive grid of cat photos in a scrollable view. Web APIs can sometimes fail, and we need to handle those failures gracefully. For example, if there's no internet connection, Retrofit throws an exception. To prevent the app from crashing, we wrap the API call in a try-catch block. If the call fails, we update the UI state to error so the app can display a helpful message. To simulate a slow API response, we add a delay call before the network request. This causes the app to pause for 1 second, giving us a chance to show a loading indicator. This kind of delay is useful during development to test how the app handles waiting states. Next, we introduce an error screen composable that shows a large error icon and a message. We modify catsapp.kt so that when the UI state is error, it displays this screen. You can test it by turning on airplane mode, pressing reload, and checking that the error screen appears. In this updated code, CatSap has been modified to replace the generic error text with a call to error screen when the state is error. This helps provide a more informative and visually distinct error message for the user. The error screen composable displays a centered error icon, a short error message, and a suggestion to check the internet connection. The layout uses a column to stack the components vertically and applies styling to make the error clear and attention-grabbing. We also revisit the simulated delay. This time, we call delay 1000 before making the API request and ensure the UI state is first set to loading. This creates a more realistic experience by giving the user immediate feedback that something is happening while data is being fetched. Finally, we build a loading screen composable that displays a circular progress spinner and a loading message. This is shown when the UI state is loading, giving users a clear indication that the app is busy retrieving data. It's the final piece in building a smooth and polished UI experience. To summarize, web APIs allow Android apps to interact with live data, creating more engaging and dynamic user experiences. We used Retrofit to make API calls, Coil to load and display images, and Jetpack Compose to build a reactive UI. By adding error handling and loading states, we've made the HeartCats app not just functional, but also robust and user-friendly. These tools and patterns are essential for any modern Android developer. Thanks for watching. Let me know in the comments if there are other topics you would like me to talk about. If you enjoyed this video, please like, share, and subscribe for more content on software engineering and technology. See you next time.